Alright, I got a few of these Bluetooth speaker kits from Aliexpress, the All Modules store, for amazingly cheap. I think it was only about £3 per kit. It's far cheaper than the cost of all the parts in here. And the shipping was even very reasonable, and they came pretty quickly. So it has a very limited instructions. Bluetooth audio kit has a schematic diagram and a bill of materials that continues on the back. There's 2 capacitors that need to be put in series with the speakers to give better bass response. Okay, so let's see what we have here. We have the power cable that you plug into a 5-volt supply. I think you're going to need at least a couple amp supply. A normal computer with 500 milliamps might not do the job. So you might want to get a good power supply. Got a remote control with the battery. Got a printed circuit board. This is a sort of all-in-one self-contained Bluetooth module with a little IR receiver for the remote. And you can plug a memory stick in here with MP3 files and play those if you don't want to play them through your phone. Got a 3 ICs and a crystal oscillator and 3 connectors. And we got 2 very nice speakers considering the price, and some clear acrylic for the enclosure. So the acrylic has paper protecting it from scratches, which you want to peel off. Probably while you're putting this thing together, you're going to have to be peeling off some of that. And the speakers, very good quality speakers. They have this foam connector here so that the diaphragm can move easily. Pretty big magnets. It says 4 ohms, 3 watts. So that's pretty good quality there. So these are all through-hole components. There's no surface mount anything. And in fact, if you completely fail in soldering it together correctly, that's okay, because the Bluetooth module will still play music. This circuit board is just to make pretty lights that blink a lot with the music, in time with the music. So to do that, it's got a microphone that picks up the sound coming from the speakers, or from anything actually. And it's got a little transistor here to amplify the sound from the little microphone. Let's see what kind of a transistor that is. I'll plug it into my transistor tester here. Testing, so it's an NPN transistor. You can see that. A couple of standoffs that go from the top to the bottom of the enclosure, and they basically hold the entire thing together. Some screws, a lot of little blue LEDs. I know they look transparent, but they light up blue. And then 4 resistors. Yeah, there are 4 resistors. These are 1% tolerance resistors. So according to the circuit diagram, there's a 10K resistor, a 1.5 mega ohms, 20K resistor, and a 470 ohm resistor. There are, these two are the 470 microfarad capacitors that go with the speakers. This is a 4017 counter chip. So this takes pulses coming into its clock. Clock line would be this one right here. It gets a signal from the microphone. So every time the sound signal crosses threshold that you probably set with this little trim potentiometer, it will count another increment and move the LED over. A few capacitors in here. There we go, 100 microfarads. 100 microfarads, 1 microfarad, and 2.2 microfarads. So on the printed circuit board is clearly labeled to tell you where everything goes. I saw a note somewhere that the red connector is for power and the two white connectors go to the two speakers. So you've got these three JST wires here that plug into those three things. And you have another piece of wire which presumably goes to the switch. And I'm going to wire this up so that the switch just turns this circuit off and on. And that the whole thing will be turned on when you plug in this USB cable. It will power up the Bluetooth automatically no matter what. And if you have the switch on, it will also turn on the LEDs. Because it would be nice to listen to music without the LEDs flashing. For example, if you're trying to fall asleep, you will not be able to have those LEDs flashing. Lots of nuts and bolts to hold all the parts together. And it looks like these screws come in two different lengths. And there are 4 of the longer ones. So those ones are the ones that hold the standoffs to the top and the bottom of the case. And all the other screws hold the speakers to these things, these sides, and they hold the circuit board in with those 2 screw holes, and the Bluetooth module, it has a couple of holes for screws. And that's it. I think that's everything. Yep. That's everything. So not very many components to solder. I noticed that one of these, the front side, what we'll call the front, where the Bluetooth module will go, like that. And this printed circuit board will sit just behind those holes. So that means that the LEDs need to go in here and then bend at 90 degrees to point forward. Of course, this is a clear acrylic box, so even if they were pointing up, you could still see them. But if you want them to give you maximum brightness, you would want to have them sticking out through the holes here. So you want to make sure when you solder them in that you leave a good amount of wire, and also you want to check the polarity. The longer lead is positive, and the PC board is actually labeled very conveniently plus and minus for each one of these. So you put the longer lead into plus, the shorter lead into minus, and you leave enough wire after you solder them so that they can fold forward and then poke through the hole of this front enclosure thingy. So you can decide how much you want those to stick out or not stick out. If you fold them right at the crimping, I think that will come out just about right. Yeah, so that's good. That'll make things handy. And then to hold them in place while you're soldering them, you would tend to splay the wires out a little bit so that they don't fall through and change their altitude. Now you have to worry about the order of some things, like if you're going to solder a wire to this from the switch to this board here, it's going to go through this panel. So there's the back panel. It's got a hole for the switch, and it's got a hole for the power lead to come out. And so you're going to want to peel off the paper that's going to be clamped in by the switch once you push that in there. And you're going to want to push this through and solder it to the board before you assemble the whole thing. I've sorted everything into 8 cartons. Here we have the nuts, bolts, standoffs, resistors, wires, switch, printed circuit board. Here we have the remote and the Bluetooth module. Got capacitors, a microphone, one transistor, lonely transistor, variable resistor, trim potentiometer, a couple more capacitors, the big ones, and the counter IC. So I'll put those aside for now while I put on some gloves and peel off the paper. There we go. Beautiful. There's all the pieces. Now, all the paper, backing paper. Okay, we'll begin the soldering. I highly recommend this little brochure by Mitch Altman called Soldering is Easy. Here's how to do it. So there's links. mightyohm.com/solder comic, in which he describes the key important information that you need to know to get going on soldering, at least for through-hole components. So this kit is entirely made of through-hole components, which means that you poke wires through the holes. There are also a lot of surface mount components that are much more difficult to solder. So if it were a surface mount, it would be soldering is quite difficult. But the key thing here that we're going to do is to make sure that we heat up the parts with the soldering iron. You're not trying to melt the solder with the soldering iron, you're just trying to heat up the parts so that they can melt the solder. So that's the idea here, to get the soldering iron touching both the wire that's poking through and the pad that's on the circuit board. So these little copper things are pads, or sometimes called lands, and those need to be hot enough to melt solder. And I've got my soldering iron set to about 350. I'm using regular solder, which is 63%, 6337. I think that 63 is the lead and 37 is the tin, judging from how heavy it is. So the first step of any soldering operation is always to make sure that the tip is tinned. So I've got a wet sponge here that I can wipe it on, or I have this copper tailings here, or turnings, that I can scrape it off with. Either one of those works very well. And try not to inhale the smoke. You can get a fan or something to blow the smoke out of your way, or at least hold your breath while the smoke is happening. So it's kind of useful to have this third hand tool. Sometimes there's a magnifying glass attached to these. This one seems to be lost. So I've got a big huge magnifier here that I'm using. Maybe your eyesight is better than mine. So we'll start with the resistors. There's 4 of those. And the schematic diagram says that they're 10K, 1.5 megs, 20K, and 470. So here's a guide that I made for the color code. So each of these resistors has colorful stripes on it. There's a tiny, looks like it's a 1/8 watt resistor, maybe a 1/4 watt, but anyway, it's a very small resistor. 1% tolerance, you can tell that because the last band is brown. And there'll be 4 bands before that that each stand for a digit. So in this case, a 470,000 ohm resistor would be yellow, violet, black, which stands for 470. And then the red band here, actually that's an orange band. The orange band means add 3 more zeros. So the digits are black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, 8 is gray, 9 is white. So if you have a little guide like this, you can, you don't necessarily need to remember those numbers. Alternatively, you could get out your multi-tester and measure it. Brown, yellow, black, green. So that's 1, 4, 0, 140, and then green means adds 5 more zeros after the 140. So that would be 1.4 mega ohms. Let's see if the transistor tester can tell us. Yeah, I got it pretty good. It says 1.493 kilo ohms. So that one goes in this spot here. So you bend the leads approximately the right distance apart from each other. It doesn't matter which way resistors go in, they can go in either way. But you want to poke them through on the silk screen side of the printed circuit board. And it's a good idea to push them all the way against the board there, because if they're sticking up a little bit, they can get knocked over and sometimes short out. And then you bend the leads apart from each other a little bit so that it holds it in place while you're soldering it. And then you get out your third hand tool and you have a look at your soldering iron and ask yourself, does it look like it's well tinned? And if not, wipe it off, add some fresh solder. So I'm going to hold the soldering iron against it for a few seconds. And I'm going to push some solder in and keep holding it there for another couple of seconds. And what you want is for there to be a blob of solder that's going, a nice convex blob going around the whole pad and up the wire a little bit. And I'll do the next one, hold it there for a few seconds. Put some solder in and then hold it for another couple of seconds and then take it away. So those look pretty good to me. Next thing to do is to trim off the excess wire, the leads. And when you do that, it's a good idea to hold on to the wire so it doesn't go flying across the room. And trim it as close as you can to the blob of solder that's there, but don't cut into the blob of solder. Just cut it as close as you can. And it's a good idea to use these kind of flush cutters. These can cut very close to the surface of anything. Okay, so that's one. So the next one I picked up here starts with yellow, violet, so it's 47, black, I think. So that's 470 and no more zeros, so that's 470 ohms. And 470 ohm resistor is over here. So bend the leads down, poke them through. And if you want, you could put a few components in and then solder a few components. Might be more efficient to do it that way, but I find if I do it that way, I might miss one. So I tend to do them one at a time. That way I can do a quality check on every single one that I do. That's lovely. Okay, next one. I would guess that it's brown, black, red, which would be 1, 0, 0, and then 2 more zeros. So that's 10K, I believe. So 10K resistor goes there. After a while, you get into a rhythm here, and it's very meditative. Now, the soldering iron will transfer heat much more effectively to the things that you're soldering if it has a little bit of wet solder on it. If you've just wiped it off on the sponge or the copper turnings, then add some solder to it so it's got a little blob, a little bit of wetness there. Then it can sort of form itself around the things you're touching and conduct heat much better. Okay, and the last one starts with red. Red, black, red. So that's 2, 0, 0, and then 2 more zeros. So 2, 0, 0, 0, 0. So it'll be 20K. And 20K resistor goes there. Okay, so we have all of the resistors installed, and the solder looks pretty good. So generally, when you're soldering a bunch of components like this, start with the small ones, because if you put big ones in first, they tend to get in the way of the small ones. So the resistors are the smallest thing. I suppose the next one would be a transistor. Got the little transistor here. When you put this in, you want to make sure that the flat side of the transistor matches the flat side on the printed circuit board drawing there, because it will not work very well if it's the wrong way around. And you don't have to squish this one right up against the board. It's kind of hard to do that, the way they've spaced out the leads holes. So they bend those apart a little bit. You'll notice that if it gets corroded, if it doesn't look shiny, it doesn't conduct heat very well. So you want it to always look shiny when you're about to do some soldering. Good. So the next smallest things are these little electrolytic capacitors. They are polarized. So you want to make sure that you put them in so that the wire that's next to the minus sign goes in the minus hole, and the other one goes in the plus hole. The plus wire will be a little bit longer than the minus wire. 100 microfarads, and on the circuit board, that goes down there. So this hatched area is minus, and the hollow green area is plus. So the longer lead goes in the plus side, like that. Okay, so 2.2 microfarads goes over here, sort of in the middle. And once again, put the longer lead in the green side, and the shorter lead in the hatched side with cross hatches. Bend them apart a little bit. That's looking a little bit corroded from my perspective. So I'm going to clean it off and add some more solder to it. That's good. And the last one is 1 microfarad. So 1 microfarad goes there. Make sure you get the polarity right. If you don't get the polarity right, the circuit will work for a while, and then one of the capacitors will blow up and release magic smoke. Didn't quite put enough solder on that. There we go. Great. We got the transistor and 3 capacitors, all resistors in. Next, maybe we'll do the microphone. So the left one is minus and the right one is plus. As long as you follow the outline on the board, you'll be okay. So it seats itself nicely around the circle there. Trim potentiometer. So this is a variable resistor. It says 103, which is 1, 0, and then 3 more zeros. So that's 10 kilo ohms. And it's not in the schematic diagram, interestingly enough. So I drew it in here. So basically there is a cut in the wire coming from the plus side of the power supply. And one end of the potentiometer is connected to the plus side of the power supply. The wiper and the other end of the potentiometer are connected to all these other components here. So I believe that's setting the threshold for the counter chip as to what kind of a sound signal will cause it to count one more count. So you may have to bend the leads on this so that they poke into the holes properly. So you'd want to stick it in all the way so that the leads are sticking out about 1 millimeter or 2, it looks like, for all 3 of the leads. Okay, that's the trim potentiometer. Now we're going to be adjusting it at some point by poking a long skinny screwdriver through the top of the box and adjusting this little wiper here to determine how much resistance it has, somewhere between 0 and 10 kilo ohms. I'll put it in the middle so it's about 5 kilo ohms right now. It seems to be where it was when I found it. Okay, the next component, perhaps the last component that we need to put on this board before the diodes, the LEDs, is the counter chip. You can see what that says there. Not really. And usually these things are hard to insert unless all of the pins are parallel. If they're splayed out a little bit, they probably are too wide for the circuit board. Yeah. So what I do is I bend them all together like this. And I keep looking down the edge of it to see whether they're parallel yet. When you put this in the board, you want to pay attention to this notch on the board here and make sure that it matches the notch on the chip itself. You also want to make sure that none of the pins are bent. So they could well have gotten bent in shipment or just from handling. So it'll be very hard to poke them through the holes if there's any bent ones. And if they're all straight, you'll go through the holes very nicely, just like that, and every single lead will stick up through the board nicely there. Now if the chip has a tendency to fall out, you can take a little piece of Blu-Tack or Fun-Tack, and or 2 pieces perhaps even, and stick it to the board temporarily while you're doing your soldering. That will keep it from falling out. So what I usually do is I solder 2 opposite corners to get the thing mounted firmly on the board. Then I can take the Blu-Tack off. And see, now it's firmly mounted, but it's not soldered all the way, so I'll go back and delete there. Okay, there's the IC inserted with the notch in the right direction, same place where the notch is on the printed circuit board. So LEDs are polarized. You can see one lead is longer than the other, so that's the plus wire. And there's also, if you look very carefully, you might be able to see, and if the camera's in focus, you might be able to see that there's a flat edge which is next to the minus lead. And the circuit board doesn't seem to indicate where the flat edge is, but it does indicate plus and minus. So just make sure you put the long lead into the plus hole and insert it to where these little crimp marks are on the wires. And that will give you some length that allow you to bend this over so it will stick out. It will stick out the front of the enclosure. Excess wire. Okay, that looks good. So you want them to look about like that. All LEDs are the same, so you don't have to worry about using different places. Make sure you get blurring right. One left solder, I have 2 left in the apron, so it gives 2 spare LEDs. That's nice. Bend them up so they're going to be poking through the front here like that. That looks marvelous. So those are all looking good. Oh, I see there's a couple of pads here with nothing in them yet. Those are jumper wires that we have to install. So apparently that says jumper in Chinese. So I need to get some little pieces of wire, which we conveniently have, thanks to all these cut pieces that I've been making. So just bend a piece of wire into a U shape, poke it through. I'm going to do a here. So jumpers and wire connect 2 parts of the circuit together. And that way to make the circuit board, you see a layer of copper. Around medium jumpers usually use multi-layer board. Of course, it's possible to make, so why not put those in? That's on your end. There you go. Look at this. Okay, now we're going to solder various power connections. So we have this USB plug here, which can be used to plug into a power brick. If you plug it into a computer, it might only supply half an amp, which isn't quite enough to run this Bluetooth speaker circuit. So you should definitely get a 2 amp power supply or a power brick that can source 2 amps, because half an amp is not really enough. The sound quality will be much worse if you don't give it enough current. So we've got a few different wires here. These 2 wires will be connected to the speakers a little bit later on. This wire, I've colored it red because on the Bluetooth module, it's got a red socket to plug it into there. So to remind me to plug it into the right socket, I've colored it red. The other 2 sockets, the white ones, are for the speaker wires. Put that over there. So I want the Bluetooth module to be powered on any time that this USB plug is plugged in. I want the LEDs to be powered on only if this is plugged in and if the switch is switched on. Okay, so the switch is just going to be for the LED circuit that we just soldered together. So to do that, first thing I'm going to do is to make this wire usable. So I'm going to split it. And get the 2 halves separated a little bit. Cut off some insulation. And I usually like to twist the wires, strands. I'll do that for the other end as well. Okay, I think we need more wire on the end of these also, de-insulated. I remove some strands there. So this one's going to be always on. So I'm going to just solder it onto this here. I think I'll de-insulate some more wire on this one as well. So first let's get this outer big wire off. And you want to do that carefully so as not to cut the small wires insulation. There we go. Looks like somebody has tinned the ends of those wires, so that made it harder to pull the insulation off. The glove's getting a bit shredded there. Okay. So red is positive, black is negative. And the USB power supply should be about 5.2 volts. So I twisted those together. I'm going to tin them, solder them up. Okay, so that makes it so that the Bluetooth circuit, when this is plugged in here, will be on any time that this is plugged into the 2 amp power supply. Now I have to worry about the switch here. So we're going to just switch the positive side of the power. So usually you put the common lead in the middle and the switched lead on the outer side of the switch, but it doesn't really matter in this case. So the common lead is the one coming from the power supply. I think what I'll do is I'll first tin these tabs on the switch. Put some solder on them. Then I don't have to hold on to the solder when I'm doing this part. So hold it very still, even if your fingers are starting to burn, while the solder is hardening. Because if you move it while it's hardening, you'll make a very poor connection. I'll cut off the excess wire. Give it a tug to make sure that it's sound. Looks beautiful. Okay. Now we're going to use some heat shrink insulation here. The thing about heat shrink is you have to remember to put it on before you solder. And I'll do the same thing I did a minute ago where I tinned them. Which just means get them covered with solder. There we go. Okay, so the first one is the ground wire, which is the black, or the negative wire. give it a good yank see if it's in good shape, and then you slide the insulation over it. And you can just shrink it with a lighter if you have a lighter, or you can, if you have a hot air gun, that works really well. I have this thing set to 250 Celsius right now. Okay, now the other wire we have left is the red one. Now if you want it to be class, you could get some heat shrink for the tabs. That's big enough. Something like that. But since this is going to be in a closed up box, you don't really have to worry about something touching the wires and short circuiting things. Okay, so we've got the power for the Bluetooth module here and the power for the LED module here. And I'm going to twist the wires and tin them again. I'm going to trim off a little bit because it'll be hard to poke them through the circuit board when they're a little bit splayed out at the ends. And they're going into this thing that says VCC and ground. So VCC is plus 5 or the red wire. And I see they've got 4 holes here because some people would have the Bluetooth module soldered in there so that both of them would be controlled by the switch. Okay, trim off a little bit of extra wire there. Okay, so there we have it. We've got our red wire going into VCC, black wire going into ground. And we've got the switch switching the positive so that when you switch it up, it connects these 2 wires. And then power will come down to the LED, and the power goes into the Bluetooth module connector always. So I think that's it for everything but the speakers now. So we'll just put that aside. Okay, last thing to solder up is the speakers. And so we've got two speakers, two 470 microfarad capacitors, and two sets of leads. The speakers have a little symbol on them that says plus and minus here. So the plus one will be the red one and the minus one will be the black one. You want to pay attention to that because if the two speakers are not wired with the correct polarity, they'll be fighting each other and canceling the sound out. So you want them both to have the same polarity, and that way their sound will add instead of subtract from each other. Okay, I'm going to strip off a little bit extra wire here because they left us with a very tiny amount of wire. Push those. Now, some instructions that I found for one of the vendors said to put those capacitors in series. And they're polarized, so you'd want to put the minus side on the black wire and plus side to the minus side here. And I'm going to make these pretty short. Maybe I'll put some heat shrink on those too. Okay, I'm going to cut off the excess wire. Then I'm going to put the heat shrink over there and shrink it. Tune the leads. Doesn't need to be that long. Let's see, so the plus one is the right one. Careful not to stab the speaker's diaphragm when you're doing this. There's a big magnet there that's grabbing my soldering iron. Okay, once again, trim off the excess. That looks good. That's one speaker. Do the same thing for the other speaker. Wire showing. Minus side of the capacitor. After putting heat shrink on wire. Now, if you don't have a heat shrink, so if you want to use heat shrink, you have to find some somewhere else. Just use electrolytic as well. Or have to look up the next insulator. Okay, I see that this one has solder filling up a hole that we put wire through, so I'm just going to have to patch it instead of poking through. So it'll be helpful to have the wire pre-team in that case. Just making sure we're wrapping around with it. There we go. And you want to leave soldering on the field because it's sort of delicate wire that's going to the speaker coil, and you don't want to have that become unsoldered. Okay, look at these capacitors up and rattling against things. Just enough against another. All right, I think that's it. I'm switching off the soldering iron because I believe that's all the soldering. Okay, I've figured out roughly how it goes together. There's a circuit board. If you bought the option that wasn't transparent, you would need those holes to see the LEDs, but since this is clear acrylic, we don't really need all those holes. So the circuit board is going to be screwed down to the bottom there. There'll be some standoffs connecting the top to the bottom and holding everything together. Bluetooth component gets plugged into the front, and a switch gets plugged into the back. A wire for the USB power comes in from the back. And then there's a hole on top that looks down on the trim potentiometer that you use to adjust the, I think it's adjusting the gain on the little transistor amplifier. So, and then there's end pieces that can go in any which way. They're identical square pieces. So these pieces are the top and bottom. The top has this hole in it to adjust the trim potentiometer. And let's put the standoffs on the bottom. So for those, I'm using these 4 long screws here. And it looks to me like these are perfectly symmetrical, so you don't have to worry about left and right, getting left and right correct. So those are going to hold everything else together. Those are the only 2 screws needed to make sure everything else doesn't fall apart. All right, now we're going to start bolting things together. I'll start with the side panels that hold the speakers. And I think that the speakers go completely on the inside. Alternatively, I suppose you could put them this way. No, they won't fit. Okay. So we've got a lot of screws here. You might think that you should use a jeweler's screwdriver because they're kind of small, but in fact, it's pretty loose. So you can use a PH1 or a PZ1 screwdriver. Probably work better. Now, I suggest to put them all in loosely before you tighten any one of them. Because if you tighten one and then put the next one in, it might not fit very well. So I'm wearing gloves so that I don't get so many fingerprints on the acrylic. Watch out for getting little bits of wire in your speaker. Okay, I've got all 4 screws there. You can hold them with pliers or a little tiny wrench if you have one, while you're screwing them to tighten them. I see there's a little rubber gasket on the front of the speaker that seals it against the plastic. That's a sign of good high quality speakers, that they're sealed against the enclosure. Okay, so all 4 corners now are pretty tight. That means the whole speaker is well sealed against the enclosure. Let's do that for the other one. Got any noise out there? There's milking time. Okay, there's the speakers finished. Now I'm going to have to get these capacitors out of the way of the side walls. So bend those back a bit. Final assembly. So I'll put the Bluetooth module in here into what I'll call the front panel. Okay, that's pretty well fastened. If you have Loctite, you might want to put some Loctite on the screws to prevent them from coming unscrewed from all that massive sound that's going to be vibrating them. Or you could put a dab of hot glue on them or something like that. Alright, so the next one is to put the printed circuit board on the base with its LEDs facing out. Now you want to make sure that all the wires have been trimmed here so that the thing can be fairly close to the board. Oh, actually on the screw here. Okay, so you don't want to make that one too tight or you might break something. Just tight enough so that the circuit board doesn't jiggle around, because that would be annoying. Glue gun is warmed up a little bit. I'm just going to put a little blob of hot glue on the screws here, so that they won't come undone. I suppose it doesn't matter if I get the wires hot glued a bit as well. And if you ever need to remove hot glue, just put some isopropanol on it, isopropyl alcohol or rubbing alcohol. That makes it come unstuck very well. I'm going to lose these spider webs everywhere. Alright, now it's just a matter of getting this to all come together at the same time. It's going to be a little bit tricky. So we've got some wires to plug in. Power wire. Double check to make sure the polarity is right. Actually, there's no way to really tell here. I assume these plugs only plug in one way anyway. Okay, speaker left, I guess. That's the right speaker. The other speaker. Now, if you're being careful, you probably test this before you plug it all, before you assemble it. But I'm optimistic. I think it's going to work. So we've got a lot of solder flux or something on this panel here. So much for trying to keep it clean. Okay, the front, back, sides. Let's see here. So that's going to be tricky because you got to do all the tabs at the same time, sir. Do the bottom tab first, then the two side tabs, and get this cable out of the way here. This cable's kind of in the way. Yeah, that's not so hard once you've got all the wires in the right place. Bottom tab first, and then the side tabs. Get all the wires in between the two standoffs. Looks pretty good. Now, you want to have a clear path to that trim potentiometer there and make sure that the hole in this piece here is over it. And I see this one's also a bit dirty. Static electricity makes dust cling to those plates. Okay, that's that. The long screws in place. Don't tighten them too much or you will crack the plastic, because you can see that the standoffs are actually too short. So the standoffs are not the right length to go in between the two plates of acrylic there. They're too short, and so if you were to tighten the screws too much, you will break the plastic. So just tighten them as much as you need to keep them from moving around, and maybe you could even hit him with the hot glue there. All right, I think we're ready to test it out. So there you have it. Speaker. All right, here's the moment of truth. Let's see what happens when we plug it in. Switch it off. So the first thing that will happen is that the Bluetooth module will be powered up because I've switched off the LED circuit for now. I have my power supply set to 5.2 volts and 2 amps.
Bluetooth is started. Please connect.
Okay. Wow. That's loud. It's YM069.
Connecting is okay.
Okay, good. Thank you. Works. Take out the battery thing. Okay, it seems to work. All right, let's try that again with the lights this time.
Connecting is okay.
Okay, I'm adjusting the potentiometer. That's pretty good.